This is Tally reporting to you from the 2009 PCBC conference in San Francisco, and I'm here with James from SDI Insulation. And James, can you tell me a little bit about your company?
Yes, SDI is a company that's been around for about 30 plus years in the San Francisco Bay Area. We install all types of insulation, including the spray foams, cellulose, fiberglass, any of the common ones people are familiar with. And we also get involved in some very unusual projects. And we do have a additional division starting within the company that's going to be doing energy audits in homes, being able to assess where your energy needs are, not just on the installation level, but everything from solar panel installations to HVAC systems, retrofits, or installs.
Great. Now I see that you guys have some insulation products here. Can you tell me a little bit about them?
Yeah, actually we run the gamut from all the way from fiberglass bats. This is an example of a typical attic situation demonstrating the function of bats, spray foam, and cellulose systems. We have blown-in systems for fiberglass and cellulose. Both types of spray foam, the closed cell and the open cell, often called medium density and low density, or half pound and 2 pound depending, many different names, which is a very popular product now because of the energy efficiency that is obtained even at the same R values as even at the same R values as you do for let's say fiber products.
So if you can tell me a little bit about the manufacturing of these products, what they're made out of, what makes them sustainable?
Okay, that's actually a very interesting question when it comes to the green aspects of a product or insulation in general. Fiberglass is basically made out of, you might think of it as sand. It's a silicon-based material. It has, at times, glue in it to hold the bat together, sometimes nothing in it. Let's say in a blown-in material where you're just putting it into the walls with a machine that blows it in place. It doesn't need a glue. It's just pure silicone at that point. You have your celluloses, which are basically ground-up paper for practical purposes. And then, of course, you've got cotton bats, which are made out of essentially a denim product or blue jeans and other cotton-based materials. And then all the way up to the spray foam materials, and it's kind of a ratty sample, but it's an example of what we call an open cell, or the very popular product today, the half-pound foam. And then there's the 2-pound foams, which is just basically a denser version of this. We are able to, for our clients, help them decide what material goes where, what performs best for them, for maybe their energy needs or green compliance points, or even just their budget. And we're able to design systems that's maybe a mix of these installations that achieves what they're trying to do.
Now, do these installations have any primary purposes? Like, would you put one installation in a wall versus a roof?
Yeah, in fact, the spray foam has become a very popular product to put into the roof systems and eliminate the need for venting. And by doing so, you've eliminated two of the largest energy issues in a structure, which is the heat gain in the summertime is virtually shut down by simply moving the insulation to the roof line. It has its inherent issues of, in the past, having to ventilate because there was no way to keep the moisture from condensing. Foam solves that problem. And in the wintertime, rather than venting off all your energy, trying to get rid of the moisture, you shut that down. So you've eliminated one of the biggest energy loss points in a structure and solved the moisture problem at the same time. And we're seeing that installed in everything from retrofit to brand new homes all the way up to the large scale projects that we work on, both commercial and almost semi-commercial residential, some of these large projects.
So I see, as far as the R values, the cellulose and the fiberglass seem to be the most insulating?
That would take a long explanation, because R value is one metric or one measurement that you might look at in designing a system, but it doesn't tell you everything you need to know. So I might take 3 different installations, install them all at the same R value, and get vastly different performance out of them, because the R value measured something in a very controlled, unreal test, yet when I put it in the wall, the typical performance is nowhere near that R value. So you could look at, let's say, a poorly installed fiberglass bat, which would let air movement occur through it, and you might get half the R value you think you do. I might go all the way up to the other extreme of foam, put it in the wall at even half that R value, yet it will outperform because it doesn't let air move through or within it, and you end up stopping the major way that energy is moved. which is air movement. It's not necessarily just about R value, which measures, like I said, a very specific conductive measurement in a very controlled test. So when you look at insulations and you say, well, what's the R value? The first thing should be, I've got this application, what's going to work best in that application to stop the kind of heat I'm dealing with? Is it air loss heat? Is it conducted heat? Is it radiant heat? You look at all those different things and to design the insulation that's best for that. R value may be a part of that analysis, but it's what everybody seems to start with. And it's probably the last place you look. It's the last thing that should really be in the analysis.
Okay, so if you were, let's say, to walk into a home and decide how to insulate that home, what are factors that you might look at?
Number one, what's the framing we're working with? What's the orientation of that house? What's the building use or the room's use going to be? The design of the house is going to have an impact on what we can put where. The framing depths are going to have impact on the R values we can get to both meet code requirements, because we do have code requirements for R value, and the depths of the framing types will have an impact on that. And then also the customer's budget, where they want to put their dollars. If they want to get the first biggest impact, we might select certain areas for the high performance products and then back down from there to things that are sufficient, but maybe not necessarily the top of the line. So each home is different. We have different parameters that start off restricting us what we can do. We have our Title 24 requirements. We first look at those, see if they need to be adjusted. We do a lot of adjusting of those Title 24 reports to match the product. And also the install, by the way, for builders who are building, or even homeowners building a home, you might get a Title 24 report, but by the time it gets to building that house, things have changed so much, you need to reevaluate that, because the report may be making you spend extra money in places you shouldn't or don't need to, and you could shift those dollars somewhere else. One of the frequent things we do is look at the Title 24, say, oh my goodness, you've overspecified, let's say you want to use foam, you've overspecified it in R value. Let's take some of those dollars out of the foam and put it into, let's say, a more efficient furnace. Well, you may think, well, as an insulator, why would you do that? Well, what you're ending up doing is actually helping the client produce as efficient a structure, but take their dollars and put them into something that produces some real energy efficiency payback. And if you're going after green points, we have a number of green point rating systems in addition to the Title 24. When we run into those things, you will frequently see people chasing points, okay? And I've seen some very poor decisions made based on the points they're achieving, and they're spending huge amounts of money. I mean, large, tens of thousands of dollars chasing points. And if we had been involved, we might shift that point buying, let's call it, or chasing points to out of certain areas and into areas that are actually going to produce a result and get points. And one of the general guidelines or recommendations we make is design the system properly, then get the points out of it you can, not the other way around. And that's really important these days, because we have some very well-intended, needed systems in place, like LEED for homes and then green point systems, where if you don't apply them right, you'll end up not really achieving what you want to do and spending a lot of money. They're well-intended, we need them, they're the right direction. There's some adjustment that needs to be made in those systems.
Where are you guys located?
We're located in Burlingame on Lang Road, and we cover the entire greater Bay Area and beyond. We go all the way to Tahoe and beyond, probably about halfway towards the southern border and halfway towards the Oregon border.
Great, and how would someone get in touch with you?
They would go to our website, www.sdi-insulation.com, or they call us at 650-685-5500.
Great, thank you so much for your time.
You're welcome, thank you.
Okay, this is Tali reporting to you from the 2009 PCBC conference in San Francisco. Thank you.